All right, so we're going to start off with scattergrams. Okay, I'm just going to give you guys a second to read this. You might want to hit pause and just read through this, maybe take some notes. All right, so this picture is something that I do expect you to already know when you walk in the door. So I know that it says the N-axis and the Q-axis. Those are generic terms. Normally, you will see this as the X-axis, and this is the Y-axis. That's more specific. They're using N and Q just as generic terms. Notice the origin hasn't moved. It's still in the center. Quadrant 1 is up here, upper right. Quadrant 2, upper left. Quadrant 3, lower left. And quadrant 4, lower right. Those are pretty important pieces for you guys to know. Okay, so you're given a table. They're calling this N and Q. Again, generic terms. We could call them X and Y. And they're graphing this point right here on this graph. So 3, 9 can be written as an ordered pair like this. And this means 3 to the right, up 9. So right 3, up 9, you put a dot. Now, and I know on the next page they're actually going to graph all the other points, but let's do this one at a time. So 1, 7, that means right 1, up 7. So right 1, up to 7 is right here. 2, 6 means right 2, up 6, which is right here. 4, 8, right 4, up 8 is right here. And 5, 9, right 5, up 9 is right here. Okay. Normally whenever you plot the points, you don't have to write the ordered pair next to it. I did it just for emphasis, but whenever you're doing this on your papers, you don't have to put the point address, I guess, next to it. You can just plot the point. Okay, so here's what that looks like just a little bit neater, so you might want to take a second, make sure that you are correct in your thought process of where those points go. And we'll talk more about this in a second. We're going to kind of switch over to another topic here next. Okay, so let's talk about independent and dependent variables. So assume that an authentic situation can be described by using the variables t and p. Again, generic terms. Not using x and y here, just saying generically t and p. And assume that p depends on t. So we call t the independent variable. Incidentally, this might help you out a little bit. X is your independent variable. So you would call p the dependent variable because it depends on what happens with t. So we would also say here y would be our dependent variable. Okay? X and y, independent, dependent. Y depends on what X does. Okay, so independent and dependent don't always use the alphabetical order. Okay, so let's look at these situations and let's talk about it. So, number 1, let L be the loudness in decibels of the sound produced by a foghorn that is d miles away from you. So, do the miles depend on the loudness, or does the loudness depend on the miles? It makes more sense that the loudness of something depends on how many miles away that you are from it. So we would say that your independent is D and your dependent is L. Okay, and if we were writing this as an ordered pair, the shorthand version of this would be D, comma, L. Okay, so now let's look at number 2. Okay, so a car is traveling at a speed S in miles per hour on a dry asphalt road, and the brakes are suddenly applied. Let D be the stopping distance in feet. So think about this. Does the speed of the car depend on the stopping distance, or does the stopping distance depend on the speed of the car? So it makes more sense that the stopping distance depends on how fast you're going. So your independent in this case would be S, and your dependent would be D. So if you were writing this as an ordered pair, it would be S, comma, D, and always put your parentheses around that. Okay, so whenever I do these problems, I know that I'm working them out, but I'm also going to show you what the textbook says the solution is. So here's what the textbook says about number 1. And I don't always give you enough time, so you may have to hit pause. Okay, so this is just reiterating what I've been saying. Your independent comes first. Independent variable is in the left position. The value of the dependent variable is in the right position. So it goes independent, dependent. That's the way it goes in an ordered pair. Alright, so with this problem, we are going to create a scattergram. So the question says, the average ticket prices for the Super Bowl are shown in the table on the next slide for various years. Let P be the average ticket price in dollars and N be the Super Bowl number. So part 1 says draw a scattergram of the data. Number 2 says for the Super Bowls described in the table, which Super Bowl had the highest average ticket price? What was that price? Describe the patterns you see in the prices. Okay, so with problems like this, they truly are asking you simple things. They're not asking you to go into great depth. So on number 1, we're actually going to look at the data that they give us, and then we're going to put it on a graph. So let me show you that. Okay, so here's the data. Super Bowl 1, the average ticket price was $12. All the way up to Super Bowl 45, the average ticket price was $875. Now, I'm going to graph these, or I'm going to let the textbook graph these. So check this out. Here is the graph of each of those ticket prices. So for 1, they paid $12. That's right here. And notice how, can you really tell that that's a 12, that dot is at 12? No, but you know that it's going to be really low and really close to 0, a lot closer to 0 than it will be to 100. So check out 515. 515, slightly higher than 112, but not really enough that you could tell. 1020, so notice these ticket prices. Check them out. What are they doing? They're increasing like crazy. This is called an exponential graph. Not that you really need to know that information, but it's shooting up like a skyrocket, like it's going up like crazy. So check out the question. It says, so number 1, draw the scattergram. That's what this is right here. This is just putting the dots on the graph. Number 2 says, for the Super Bowls described in the table, which Super Bowl had the highest average ticket price? It almost feels like a trick question because you look at the graph or the table and you're looking at it going, is it really that easy? The highest average ticket price is right there, right? $875 for Super Bowl number 45. I'm sure it's higher than that now. However, this is all we have on this table, so don't worry about data that isn't on this table. So, number 2, for the Super Bowls described, which Super Bowl had the highest average ticket price? So 45. And what was that price? It was $875. It really is just that easy, so don't freak out whenever you read these going, oh, there's too many words. Okay, so describe any patterns you see in the prices. What is the pattern? The pattern is it is increasing. Seriously, it really is just that easy. Don't make it out to be something that it isn't. All right, so again, this is the answer to number 1. You don't have to draw the line on these. You don't have to connect the dots. But just put the dots on the table. So then number 2, again, for the Super Bowls described, the highest average ticket price is $875, and it was for Super Bowl 45. And then I'm going to go ahead and let you read through this part too. It's got a pretty good explanation. Probably a little bit better than the way I could word it. So again, you might want to hit pause and read through this. Okay, so for this problem, it says we are creating a scattergram with zigzag lines on an axis. So zigzag lines is probably something that you may or may not have seen before, and so I'm going to explain that here in just a second. So let's look at the problem first. A life expectancy is a prediction of how long a person will live. The table on the next slide shows life expectancies at birth for Americans in various years. Let L be the life expectancy at birth in years for an American born T years after 1980. So just so you understand, if I say T is equal to 2, that means I'm talking about 1982. Okay? Because T years after 1980. That's just an example. Okay, so then it says create a scattergram of the data and then describe any patterns in life expectancies of Americans. All right, so let's look at the data. Here's the data. Year of birth is 1980. The life expectancy was 73.7 years. In 85, which by the way would be T is 5, this would be T is 0. The life expectancy is 74.7. 1990 is 10 years after 1980, and the life expectancy is 75.4. 95 is 15 years, and the life expectancy is 75.8. 2000 is 20 years later, 76.9. 2005 is 25 years later, 77.4 years. And 2010 is 30 years later, and the life expectancy is 78.3. Check out the trend here: 73, 74, 75, 75, 76, 77, 78. So part 2, where it said, what is the trend that you see that it's increasing. We'll talk more about that in a second. Okay, so they converted that table to the same numbers that I showed you just a second ago: 0, 5, 10, 15, 20, 25, 30, and the life expectancy in years did not change. So now if you graph that, notice how on our t-axis, which is also our independent axis, they're counting by ones. Even though they only label every 5th one, they still are labeling this, or they give you a tick mark for each year. It's just it gets too squished whenever you try to label every single year, so that's why they are only labeling every 5, but they do give you a tick mark for every year. Now, what I really want you to see, and this is the zigzag thing that I'm talking about, is this thing right here. That's a zigzag. That means that there's a break in the graph. So we're not going to start at 0 and count by 72, otherwise this wouldn't be 73, it would be 144. Okay, so that's why, and I'm going to erase that, that's why there is a zigzag right here. So there's a break in the graph. We're not showing you 0 through 71. We're going to start it at 72, and then we're counting by ones on that dependent axis. Okay, so that's why you had to use the zigzag, because there was a break in the graph. So at at 0, we have 73.7, so that's where that dot comes from. At 5, we have 74.7, 10, 75.4, and it all goes back to that chart that I showed you just on the previous page, this chart right here. They're graphing those points on this graph right here. So do you see how the trend is that the life expectancy is increasing, which is what part 2 says. Now, I do want you to read through this, because this statement right here is significant. The zigzag lines help us see that the trend is increasing. Otherwise, the graph would look darn near flat. Okay, if you did not do a break in the graph, then it would look like this. And do you see how flat that is? So that's why we really had to do the zigzag, to see that there was an increase in in life expectancy. Okay, so let's look at bar graphs. Bar graphs are probably some of my favorites because I think they're just so easy to read. A bar graph is a diagram with two axes that we can use to compare measurements of two or more items. Along one axis we list the items, so that's the list right here, it's down here at the bottom. And along the other axis we mark tick marks. And we write numbers and write the units of measurement. So notice here's the units of measurements, dollars. We use a bar to indicate the measurement of each item. So if you look at Annie, Annie is right here. And it's, of course that line, I didn't draw it exactly straight, but it's slightly higher than 50. So Annie made over $50 million. Okay, so now let's look at the Rocky Horror Picture Show. It's more than 100, but less than 125. This tick mark would represent 125. So if I said approximately what was the revenue of the Rocky Horror Picture Show, if you gave me an answer of 115 or 120, I would have to take it because I can't tell exactly where that line is. I do know that it's more than 100. I do know that it's less than 125. Pretty much any number you give me in between there, I would accept. Same thing with Greece. Look at Greece. This tick mark, even though it's not labeled, it does represent 175. So Greece would be more than 175 but less than 200, and I would have to accept some answer that you came up with in between there because I can't tell exactly either, just like you can't. Okay, so this question says, estimate the revenue of the Rocky Horror Picture Show. So again, going back to that table, the Rocky Horror Picture Show, I know that it's more than 100 but less than 125. So if I estimate the revenue in between that number, I would get it right. So more than 100, less than 125. If somebody told me 120, don't forget to write either million or you would have to write that. And don't forget your dollar sign. So if you gave me that answer, I would have to count it as correct. It has to be more than 100 but less than 125. So then the question number 2 says, which Broadway-based movie musical listed in the bar graph has the largest revenue? So that we're looking for the one with the tallest bar. And what is the revenue? We can only approximate. We can't come exactly. The tallest one is Grease, so that answers part 1. And its revenue is more than 175 but less than 200. So if you told me, let's say 185, I would have to take it because I can't tell either. I can only estimate. The textbook is saying 188 million. I would accept that answer. That's a good answer. But again, they can't tell exactly either unless they're measuring exact. And maybe they are, maybe they aren't. I can't tell. But 188 million would be a good answer. It's greater than 175, but it's less than 200. Okay, so plotting points in a coordinate system. When we plot points that are not being used to describe authentic situations, we call the horizontal axis the x-axis. So again, we're not talking about something specific. It's kind of our generic go-to is x and y, even though earlier they were using other variables. Again, generic is going to be x and y. The x is your independent, your y is your dependent. So the ordered pair 6, 3 means right 6, up 3, put a dot. So let's plot some of these points. 3, 4 right here says right 3, up 4, so it's right here. Negative 5, negative 3 means left 5, down 3, so it's right here. Negative 4, negative 2 means left 4, up 2. Left 4, up 2 is right here. 5, negative 4 is to the right 5 and down 4, which is down here. Okay, I was wondering where they put those other 2 dots. I put them on the last graph, but notice how negative 4, 2 is left 4, up 2, and 5, negative 4 is to the right 5 and down 4. Alright, so that's it for this video. I hope this helps. You guys have a great day.